Welcome to this CCC tutorial. In this tutorial we will show how you can use the CCC in different ways.
And yes, if we look into the basis for the CCC, we have a bottom-up calculation of the energy usage in different coating lines. We have industry verified parameters. The values that we have put in is not just coming from the air. It's plant suppliers, and we have had Mayer and Jurt who are also verifying the figures. We have built a model with full transparency, which means that you can see and follow the changes you do. And we have created 4 standard lines with full cost breakdown, so you can look into the investment cost also. The lines are, this is the small line, or actually we can start with the object size. All lines are dimensioned for an object that is 3 meter long, 600 deep, 1.5 meter high. And there is an investment cost of this line, the small line, of 1.2 million, and it runs with a conveyor speed of 1 meter per minute. The medium line, same object size, running with a speed of 2 meter per minute, has an investment cost of 1.4 million euro. The large, running with 3 meter per minute and have an investment cost of 1.6 million euro. The 4th line is a manual line. Here we have recalculated the capacity to reach a speed of 0.25 meter per minute, and we have an investment cost of around 100,000 euro. For all these lines, these 4 lines is very much the industry standard, and this is the lines we see when we are traveling around and visit customers around the world.
So now we are going to look at the basic functionality of the CCC application. It's, if you log into HangOn CCC.com, you have a menu choice called CCC Calculator. And then you will arrive at the landing page of the CCC. And what you see here is basically cases. And we have 4 different kind of cases in the CCC. We have something we call the quick guide, which consists of the standard line that you just heard about, which you can combine with a number of standard objects in different geometries. Then we have real customer cases, which you can learn from. And we have standard cases. And lastly, if you are logged in, you will also see your own cases, which you can create. But we will start off with standard cases. And this is a case we have used for our green effect information, which you will hear later about. So when you open the case, you will come to a summary where you see 2 production setup. Setup 1 on the left side and setup 2 on the right side. We have 9 or 8 parameters basically, which you can adjust and make simulations. How many staff you have on the line, number of shifts, whether you have handling time offline, coating objects area and weight, the speed of the line, and then 2 parameters which in combination calculates the hanging density, and that's the number of hanging points per hanger and the center-center distance between the hanging points. And in this case, we are just comparing a typical daisy chain hanging with one of our new products called HQWS, where we hang 5 instead of 3, which increased the hanging density from 17 pieces to 28. And that gives a cost saving of 30%. We have a full cost breakdown on 6 categories. We have fixed line, energy, blue collar, staff cost, cost for the powder, hanging point, and finally general overhead. Now, if you are a logged in customer, it will look more or less the same, but you will have some additional information. You will see a total coating cost calculated. And you will also have access to all the parameters that decide the line cost, as well as energy, CO2 equivalents, coating objects and powder, and finally the cost for hanging. We are not going to go through all the parameters here. We'll just demonstrate how you can simulate with some of the values and what impact it has on the CCC. So for instance, let's say that you have an old line and you want to use the book value, and let's say it's just half of the new cost price. So we enter 700,000 euro here. And the saving were 30%, and we see that has a very marginal impact on the cost saving. Just 3%. We change back. We see that it was 30% from the beginning. If we look at energy, in the standard calculation we have used 20 euro cent as cost. So let's say that we have a 50% increase of energy. What will the impact be then? Then we have a decrease of savings of 7%. So it has an impact, but also that is not massive. What about the powder cost? Let's say that we have a much more expensive powder. We have calculated a cost of, or used a cost of 7 euro per kilo. Let's say we play with 10 euro per kilo. It just changed the savings with 3%. So powder has a very small impact. Now this should be said that this is a small object, so it will be a different story with a bigger object. The final parameter I want to touch up on is productivity. What do we mean with productivity? We mean of the planned time, how much of the planned time are being used as the specified speed of the line and hanging density. We have calculated as a standard 70%. And the rest of the time, for this you have normal stop as color changes, but also technical breakdowns. You can have problem with logistic, so you have to, you're running the line empty. So say that you have a decrease of productivity to 50%. How much does that impact the calculation? Here we see that we almost lose the whole saving. So with these small simulations, we can conclude that efficiency, meaning the combination of the productivity and hanging density, by far has the biggest impact on the cost structure of a coating process. In this section, we will demonstrate how you can use our new quick guide for benchmarking your own projects and objects. You find it here to the left. And you start with selecting one of our standard lines. And the whole idea with this quick guide is that you, in 3 simple steps, can simulate something that are similar. You can't work with your exact own line, but working with standard lines and object to make a combination of cases in 3 simple steps. So I will just select the medium line here. And then I come to a view where I have 6 different object types. Small, medium, large, long, sheet, and heavy objects. So when I select one, for instance, small, I will have a small description of the object. In this case, a headlight holder, 0.02 square meters and 0.18 kilos. The hanging method is single hook, giving 8 pieces per meter. And then I have 2 alternative hanging scenarios which I can compare with. So I will just select the HQWS here. So now we have actually created a case with all the parameters. And if you are logged in or are a user, you can play with all parameters here. So the idea is, if you have a small object, you can use this as a comparison case, and you get a pretty good idea how the cost structure looks. The dominant one is the fixed cost, energy, and blue color, whereas powder and hanging points are very small. One of the good things with this is that it's very hard to foresee how different objects will come out in the production setup. So let's say that we play with a large object, and we start with what we call the wire basket. So this is actually hanging pretty efficient, 45 degrees using the depth of the painting cube. Anyhow, we are not utilizing the full height. And as it is a wire construction, we have no problem with application if we hang it double-sided. So we're actually doubling the hanging density here in this case. And it gives a pretty good saving. If we compare with the cost structure with the small headlight holder, it's pretty similar. But of course, a wire construction doesn't need so much powder. So what happens if we look at another large object, a sheet metal box or drawer, which are 1.2 square meters, so a much bigger area to be coated. And here we see a difference in the powder consumption. Here it's over 30% compared to less than 10% for the small or wire construction. But still, it doesn't take away the effect of efficiency or hanging density. We have a savings of 23%. And let's say that we can use a powder that are 15% less expensive. So €6. Yeah, of course that has an impact, but it's just 4%, as the original saving was 23 coming from and of course we need more staff to hang this, but as we can see, that doesn't matter, and you can play with a number. Let's say that we need another staff. It has a very small impact. The final thing I want to show is the bracket here. Where we're comparing also single hook hanging with the HQWD, which actually exactly doubles the hanging density. Then we have a new function called detailed results. And here you can actually put in a cost analysis for the project. So let's say you have 2,000 pieces and we are paid or we are selling this for 55 euro cent, or your cost are that. Then we have a project income statement. And let's also say that we have a startup cost of 100 euro. So based on all the parameters now, we have a project income statement. So with the hook hanging, we are earning 55 euro, and with the HQWS, it's 400. And here, of course, you can make simulation. Let's say we only have 1,000 to coat. What happens then? Yeah, then we are running into a loss. So this is some way you can use your quick guide. we know in practice that it's difficult to really know what potential I have in my line, because we have many different objects, and it's difficult to overview both your current performance and the line potential. So in the next section, we will show a way how you can look at the potential, will simplify to just use one standard object for a full year. The third version of cases is real customer cases. And I will show one of the cases from a customer close to us here in Sweden. They are manufacturing shelf systems, and as with all customer cases, there is an overview video about the company, etc., which you can look at afterwards. But in this case, it was about the beams in the shelves. And they really had a growth program and needed higher capacity. And they used to daisy chain hang this like this. And we made a new solution for them, where we actually doubled exactly the hanging density. But here was also some other interesting factors, that they were running the line very fast due to capacity problems, which is not good because they consume too much powder. So we lowered the speed, but the relative effect was still 50% increase in output. And they were producing 240,000 beams. So just this also. They could make a saving of 200,000 on the existing volume. And that was also because they could reduce the powder thickness drastically. So they had a big saving on powder also from running slower. But it was also a quick effect that they could work faster with hanging the beams. So a very interesting case. And there are more cases for you to study and get inspiration from on the homepage. So now we have reached the final section, and that's how you can create your own cases. And here we have made a lot of improvements. So there is a guide where you can, based on standard object, you can just copy them and change what you want to change. And I will just run through it so you can see how easily you can do it. And it's the Add New Case button here. And you select a customer, and that should be set when you have a user. Everything will just be saved to your company. So of course, other companies can't see what you are creating here. I can select a standard line and just work with it. But now I will want to make some adjustments. So I take a template and I take the large line, which is closest to mine. but I want to change the investment cost to 1 million. And also the staff cost, I changed that. Energy, I don't want to make any changes. The CO2 equivalent, we will use Germany here, as I put it for a German customer. And I will simulate the dollar case. So I will just use standard object here. So I get that in with all parameters, and then I do the hanging. And I need a daisy chain in setup 1, and in setup 2 I will use the HQWS, and there are a number of standards, so I will search for it. And this is the one that is created. And then I just give it a name. Test webinar or something. I can pick up the pictures, which is always nice, both for the case picture and the case images. And then I just press save. And I have my case saved with my own adjustment to my real, which I can play around, which we have demonstrated throughout the webinar. And it will be under my cases here. So here is the new case.